Okay, so now we are going to look at the spread. Now we've already looked at different types of averages and what they can mean for our data. So here we're going to look at what the spread of our data means. So when we've worked out our average, it's one thing just to have that number, but we need to think about how consistent our data is. So when we're thinking about spread in mathematical terms, that's just how consistent our data is. The more spread out your data is, the less consistent it is. So if we think about this set of numbers, we've got 5, 5, 6, 6, 7, 7 and 8, and we think about what that looks like. Okay, it's quite compact, reasonably close together. If we take a different set, okay, so there's still 7 numbers in this set, 1, 2, 4, 5, 7, 8 and 9, and we think about where they are, we can see straight away that that set is a lot more spread out than the one above it. Okay, it's a lot less compact, it's a lot less consistent. So we need to have a way of measuring that as well. So there are 3 types of measures that we'll look at here. The first one is the range. So the range is one of the easiest ones to work out. Okay, it is found simply by taking the highest value in your set and subtracting the lowest value. So let's take a look at an example. We're going to find the range of this data set. So we've got 2, 3, 3, 4, 4, 5, 5, 6, 7 and 8. So again, we get the advantage that our data is already in order. So I can see my smallest value is 2, highest value is 8. So range, maximum minus the minimum, which is 8 minus 2. So that gives me a range of just 6. And so that range just tells me how many numbers my data is spread out over. Okay, so it just goes between 2 and 8. It covers 6 things. Another set, again, data is in order, so we're going from 12 up to 16 here. So my range, maximum minus minimum, 16 minus 12, that gives me a range of 4. And one last one, 14, 12, 15, 17, 19, 20, 15, 16 and 17. So this time my data is not in order. Depending on what it is we're asking for you in the question, you might want to order it first, but if you're just looking to find the range, you can probably look through it and find the smallest and the largest values without too much fuss. Okay, but if there is more to the question, we would tend to ask you, or expect you, just to order those numbers first and make everything a little bit easier. Okay, it's unlikely that we'll ever ask you just to find the range of a data set. There's always more to it than that. But again, think about what a range is. It's the maximum number minus the minimum number. So 20 minus 12, in this case, biggest number 20, smallest number 12, and it gives me a range of 6. Okay, so looking at my 3 data sets that are there, the one in the middle actually happens to be the most consistent there. It's the least spread out because it covers the smallest range. Thinking about another measure then is our semi-interquartile range and our interquartile range. Okay, so depending on which course it is we're doing, they will ask you one or the other. So these are both measures of spread. Okay, but this time what they do is they require us to use the quartiles of our set of data. We also don't ever expect you to write out all those big words. We will just shorten them to SIQR and IQR. Okay, so you don't have to keep writing out all those words. And remember how to spell interquartile. So, what actually are they? Let's start with the interquartile range. We're going to find it of the following set of data: 2, 3, 3, 4, 4, 5, 6, 6, 7, 8, and 10. So, our interquartile range is just the range between our quartiles. So we need to do the highest quartile minus the lowest quartile. So before, when we found the range, it was just the highest value minus the lowest value. Here, our interquartile range is the highest quartile minus the lowest quartile, which means we're actually going to need to find these quartiles. So quartile 1, our lower quartile, is 3, and our upper quartile is 7. Again, if we can't remember how to look at that, we should go back and have a look at the other bit in our other clip where we have a look about finding our 5-figure summaries. So shove my numbers in. My interquartile range then, 7 minus 3. 7 minus 3 is just 4. Similarly, we're going to ask you to find the semi-interquartile range, and so all we're doing here is thinking about what is the semi-interquartile range. Well, it's just the interquartile range divided by 2. Okay, so we think about where we see the word semi, you think about semicircle, it's just half of a circle. Okay, so here, the semi-interquartile range is just half of that interquartile range. So, shove my numbers in. Upper quartile 7 minus lower quartile of 3. divided by 2. So 7 minus 3 is 4. 4 divided by 2 gives me a semi-interquartile range of just 2. Okay, so formulas that you'll need to remember that we don't provide you with is what they both are. Okay, if the absolute worst comes to it, you can almost piece it together by just taking what the words are actually telling you. Okay, or if you don't want to do that, you can just remember the formulas. Okay, moving on then to the third, the most complicated looking of all our measures of spread, but probably one of the most asked about and one of the better ones that you can be using is our standard deviation. Now, this measures how far most of your data lies from the mean. Okay, some of the time it will take into account all of your data, some of the time it will just take into account most of your data. It will depend how accurate you're being in terms of decimal places and things. But it can be found, by one of two formulas. Okay, just now they are both on the formula sheet, and it is up to you which one you want to use. So I'll do an example where we do one of each, and then we'll look at standard question. I prefer to use the second formula, so a second example will then cover that one, but we'll do some more in another video so you can have a wee look, because this is actually quite an important thing for you to be able to do, and it looks quite complicated. So before we start, we'll have a look at some of the notation that we might not have seen before. So the first thing that's probably jumping out at you as being kind of unfriendly is this funny E thing. Okay, that's actually just a Greek letter, sigma. It means, we use it to mean sum, okay, or add up. So thinking about how we're seeing it in these equations, so sigma in use, the sigma x just means sum of x, so add up all the things. If we were asking you the sum of x squared, you're going to square all those things and then add them up. Okay, so the big sigma thing is telling you you're going to add up whatever things it is that are coming after it. Another symbol we might not have seen before is this x with a little line over the top of it, pronounced just x bar. Okay, here this actually just means the mean. Okay, so rather than write the word mean in the formula, we've come up with another little symbol of it. So just x bar needs it just to mean the mean here. N, probably the nicest of the things that we could have here, just tells us how many numbers are in our data set. Okay, how many things is it we're actually dealing with. An important little reminder, when we want to find the mean, all we're doing is we're going to add up all the things in our data and divide by how many were there. And so thinking about our new notation and how we can link it in, if we ask you to find the sum of x, we're just asking you to add up all the things that are there, divided by n, and divided by how many things were there. So if we ask you to find the mean, that is the notation that we can sometimes see refer to that. Okay, so moving on then, let's have a look at an actual example. So we want you to find the standard deviation of the following set of data. So we get 6, 7, 9, 9, 10 and 13, and we want you to use the first formula that's there. So the standard deviation is equal to the square root of the sum of x minus x bar squared all over n minus 1. So taking it as it comes, the first thing we're going to want to try and find is this thing on the top, this sum of x minus x bar squared. And so we're going to start our table. And so I'm just going to piece it together. I've got x, and then I've got x minus x bar, and then I've got x minus x bar squared. We're just building that up. So in my first column, the x column, all I'm doing is I'm just putting my data that's already there. Okay, so nothing overly challenging has to happen there. You're just writing your numbers out again. Okay, and this number at the bottom is my sum of x. So that's actually just the number I get when I add them all up. So in order to fill out the next column, I need to have x bar. Okay, I need to be able to take away this x with a funny line over the top of it. Remember, x bar is just the mean. So what we need to do is we need to work out the mean of this set of data. So we need to know what we get when we add them all up, and we need to know how many there are. So my sum of x was 54, and there were 6 things in my list. So my mean, sum of x divided by n, 54 divided by 6, and that gives me a mean of 9. So again, remember, all we're doing is we're trying to avoid doing too much work more than once. So here in my table, down in my bottom left, I've already added up the numbers. So I don't need to do it again when I'm coming to work out my mean. That's the whole point from trying to do our table first. So I've worked out my mean to be 9. What I need to do now in this middle column of my table is I need to take each of the values that are already there and I need to subtract 9 from them. So in the first one, we've got 6 minus 9 is minus 3. Next one, 7 minus 9 is minus 2. Next one is 9 minus 9 gives us 0, 9 minus 9 gives us 0, 10 minus 9 is 1, 13 minus 9 is 4. So when you're coming to do this, you don't have to write out the takeaway sum in every single thing, but I've done it here just to make sure that you know what it is that we've got going on. Okay, again, my sum of x minus x bar down the bottom is 0. It should always give you 0, or very close to 0. But again, that's not a number that you actually need for your sums. Okay, that's just us showing how we're progressing through this. So that there is my sum of x minus x bar. Okay, and what we want is we want the sum of x minus x bar squared. So that is going to mean we need to find out the number. So all we're going to do is take what x minus x bar was in the middle column and square it. So minus 3 times minus 3 is 9, minus 2 times minus 2 is 4, 0 times 0 is 0, 1 times 1 is 1, 4 times 4 is 16. And then right on the bottom, I've added them all up, and that comes to 30. And so that number there, in the very bottom right box, is my sum of x minus x bar squared. So just now, it still looks very complicated, but actually, we haven't done anything overly challenging at this point. Okay, we've multiplied, we've divided, we've added, we've subtracted, we've done our 4 basic operations, but that's really all we've done at this point. Next thing we're going to do is we're going to think about where these things go in my formula. So my sum of x minus x bar squared was 30. N that we're dealing with here is 6, so we're going to have the square root of 30 over 6 minus 1. So first thing I'm going to do is I'm going to tidy that up, and that just becomes the square root of 30 over 5. And depending on the type of calculator you've got, you can either start asking it to tell you what the answer is now, or you might need to kind of work it out a little bit more first. Okay, reduce your fraction a wee bit, but you can ask it now. Square root of 6 and gives you a standard deviation of 2.449. Okay, so what we're saying is that most of our numbers lie 2.5 either side of the mean. So 2.5 above 9 and 2.5 below 9. Okay, and that's pretty much the case. So another one then, we're going to try using the other formula. And the other formula looks a lot more complicated. Okay, looks a lot more complicated mainly because it's got this sigma in it twice. Okay, but it's not any more difficult than the previous one. So we're going to ask you here, find the standard deviation of the following data. We've got 3, 5, 2, 9, 1, and 8. So I've drawn out a table. This time there's only 2 columns in it, x and x squared. So the first thing I'm going to do is put my data in the x column. And I've already summed it up at the bottom, so when I add up all the numbers in the list, it comes to 28. So that's the sum of x. What I need to do now is numbers. And so when I square all those numbers, I just write it in the other column. So 3 squared is 9, 5 squared is 25, 2 squared is 4, 9 squared is 81, etc. And at the very bottom, I've added up all of them to find me my sum of x squared. What I'm going to start doing is I'm going to start trying to put what I've got into my formula now. And when I do that, it ends up looking like this. So my sum of x squared is the first thing. So my sum of the x squared column, so 184, minus the sum of x all squared, so 28 all squared, divided by 6, all of this over 6 minus 1. So again, depending on the type of calculator you've got, your calculator might be able to handle all of that to start with, but you'll need to be very careful where you put in your brackets in. So my advice is the first thing we're going to try and do is we're going to try and sort out this fraction bit here on the top. What I want to do is change this bit into just a number. Let's see if I can find out what number should just go there. So 28 squared gives me 784. 784 divided by 6 is 130.6666. But we've rounded it there, and we've put a 7. So next thing I'm going to do is I'm going to substitute that number in place of this horrible fraction. So I've actually got 184 minus 130.6667 divided by 5. Okay, and again, that number there, that 130.66, was subject to me rounding it. Okay, so try and be sensible when you're rounding it. Try and keep at least 3 or 4 decimal places, just so that you don't lose your accuracy within your working. I'm going to try and tidy it up a little bit more, so I'm going to do the subtraction on the top first. So 184 minus 130.6667 is going to give me 53.3333 divided by 5. Chucking that into my calculator, that gives me a standard deviation of 3.266. Okay, in these questions, we haven't actually asked you to do anything with the standard deviation, you've just had to work it out. And so we don't really know here whether the numbers we're finding are correct, what they mean, and how they might reference something. So a particular type of question that we often get asked in our exams or in our tests, we might ask you something like this. So for example, 6 boxes contain the following number of jelly beans per box. So we've got 28, 27, 29, 30, 32 and 28. Part A, find the mean and standard deviation of the above data. Okay, so our first part here wants us to find one of the types of averages and one of our types of spread. So what we're going to do is, first thing I've done is drawn out my table, and I'm reminding myself of what my formula is. Okay, again, formula's on the formula sheet, so you don't have to remember it. Okay, just make sure you can copy it down correctly. So it's a good idea, as one of the first things you're doing, to make sure you get that on your page. Next thing I'm doing is I'm going to list. And so I've got my X column there, 28, 27, 29, 30, 32 and 24. And I've summed them all up to give me 174. In the other column, whilst we're here, all I've done is I've squared each of those numbers. So 28 squared gives me 784, 27 squared gives me 729, 29 squared 841, and so on. And then right down the very bottom right hand box of that table, I've added up all the things in the X squared column. So that there is my sum of X. And that's going to come in handy up here because I want to find my mean. First thing it asked me to do in the question was find the mean. And so we find the mean by adding up all our values and dividing by how many values were there. But remembering from my table here, that's what I was going to be doing anyway. So I've done my table first so that I don't have to spend my time adding up these numbers more than once. When we ask people to do these questions, they tend to do the mean, and they'll sit and type in all these numbers into their calculator, and they'll add them all up, they'll divide it by 6, get their answer, and then they come to the next part to find their standard deviation. They put all the numbers into the table, and then they add them all up again. Don't do it twice, it is a total waste of your time. However, once we've done it, 174 divided by 6 gives us our standard deviation of 29. No, it doesn't. It gives us our mean of 29, sorry. So moving on to our standard deviation, we've got x, the sum of x squared minus the sum of x all squared divided by n all over n minus 1. So we need to use our sum of x squared here as well, and we're going to put these numbers into our formula. So the sum of x squared is 5062 minus the sum of x, which was 174 all squared divided by 6 all over 6 minus 1. So again, first thing I'm going to try and do is I'm going to try and get rid of this fraction bit. I'm just going to work out what number it actually is. So over at the side, I'm doing 174 squared, and I'm remembering to press equals. And it's giving me 30,276. I then divide that by 6, and that gives me 5,046. So again, we're not dealing with small numbers here, right? These are still large numbers, but there's a couple of clues when we're working through this that kind of remind us that we're on the right track. When we're looking at doing these, and we come to this line that we've just typed up here where it's 5062 minus 5046, those numbers should be roughly similar. Right? Now, as long as they're both massively horrible numbers, you're probably still doing it right. And crucially, the number on the left should be bigger than the number on the right. Okay, if the number on the left, this 5062, is smaller than the number on the right, then your standard deviation isn't going to work, because you're going to end up having a negative number and you can't square root that negative number. Okay, so that's your clue then that you've made a mistake and you need to go back and have a look. Right, but here, our numbers meet the conditions. One on the left is bigger and they're both about the same size, they're 5,000 and something. So 5062 minus 5046 is 12, and so our standard deviation here is the square root of 12 over 5. chuck it into our calculator, and we get 1.549. Remember when we're doing this, do not forget our square root. Remember, the square root covers everything here. Okay, so let's not take that too soon. So I've worked out my mean, it was 29, and I've worked out my standard deviation of 1.549. So I've got an average, and I've got a number that tells me how consistent the data was. Moving on then to part B. So they take another sample and find the mean amount of jelly beans to be 30 and the standard deviation to be 1.893. We want you to make two valid comparisons about the number of jelly beans per box here. So when we are asking you to do these things, you need to make sure that you make one comment about the mean and one comment about the standard deviation. Okay, remembering one is an average and one is a measure of spread. So the first thing we're going to do is we're actually just going to compare our values. Okay, because when we're working these out, they tend to be all over the place and it becomes very difficult to compare. So first thing I'm doing here is I've got my mean. So my first sample, the mean was 29. The second sample, my mean was 30. Looking at my standard deviations, my first one was 1.549, second one, 1.893. So comparing our values. Next thing we're going to do is we want to comment on which average is better. So on average, we can see the second sample had more jelly beans per box. So there's my first comment. Next comment I want to do is I want to talk about which one was more consistent. And so our second comment then, however, as the first sample has a lower standard deviation, they were more consistent. Okay, and as a rule, when we are looking through these, the one with the smaller standard deviation is the one that's more consistent. And that's what it is that we're trying to do. The smaller our standard deviation, the more consistent our data is. Okay, and it doesn't matter what the conditions are, it doesn't matter what the context is, that's always going to be the case. The smaller the standard deviation, the more consistent your data is. And if the worst comes to it, and you can't remember how to spell consistent, just go for less spread out.